Lesson 23.2, Normal Distributions. How do you find percents of data and probabilities of events associated with normal distributions? Need to make me a little white space here. All right. And then let's make that blue, make it solid. Draw some flat line here. All right. And let's see here. Right down the middle there. That's our mean, right? Okay, and then you got an inflection here. We'd say that's 1 standard deviation, and then you got an inflection over here. That's -1 standard deviation. And then down here, it kind of cups. That's 2 standard deviations. Down here where it kind of cups, that's -2 standard deviations. And then, of course, down here somewhere is 3 standard deviations. And then over here, -3 standard deviations. That's negative. All right. So how does that help us? Well, we know that on this side over here is half the data, and then over on this side here is half the data, right? Okay. Well, from 1 standard deviation plus or minus 1 standard deviation is 68% of the data. Okay, so that means that's like 34%. That's like 34%. Okay, and then right here, from here to here is 95% of the data. Okay, so that's going to put that at 13.5%. And this is going to be 13.5%, right? And then if you go 3 standard deviations, that's 99.7% of the data. So what is that's 4.7? Yeah, 4.7. 4.7, divide that by 2, and you got it's 2, and then 3, and then 5. Okay, so that's 2.35% of the data, and that's 2.35% of the data. Okay, that helps you find the percents. Okay. Substituting a normal curve for a symmetric histogram. The table below gives the mass in kilograms of 20 babies at birth. You know there are 20 babies because that is the sum of the frequencies. You also know that the masses are normally distributed because the mass with the greatest frequency occurs at the center of the distribution, and other frequencies taper off symmetrically from that center. The mean of the data is 3.5 kilograms, and the standard deviation is 0.14 kilograms. You can use a graphing calculator to draw a smooth bell-shaped curve called a normal curve that captures the shape of the histogram. A normal curve has a property that the area under the curve and above the x-axis is 1. This means that you must adjust the heights of the bars in the histogram so that the sum of the areas of the bars is 1. Find the relative frequency. All right, so let's see here. 2 over 20 is 0.1. 4 over 20 is 0.2. 6 over 20 is 0.3, and that's 0.2, 0.1, 0.05. Adjusted bar height. Now you have to do this for the 83 and the 84, but you don't have to really do it for the inspire. So that would give you 1, 2, 3, 2, 1, and then 0.5. And what is the sum of the relative frequencies? It's 1. If you add all of those up, it equals 1. All right. For we already did that. Let's see. Enter each mass in from the table, L1 into your graph, and enter each adjusted bar height into L2. Okay, let's go to our calculator. And we're going to go lists and spreadsheets. And up here, we're going to put mass, M-A-S-S. Okay, so we've got 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8. All right, and we'll put relative frequency here. Misspelled that. Relative frequency, abbreviated a little bit. 0.05, 0.1, that's supposed to be 0.1, 0.2, 0.3, 0.2, 0.1, 0.05. All right, we're back up in the data. Now let's go over here and let's press on and bar graph. Down here, mass, and over here. And now we want to press Control menu, adds Y summary list, and relative frequency. Now there's some space between these, and we can fix that easy. Menu, 2, 2, 2, 1, and we'll put in 0.1. All right, we got that fixed. Not a problem. Okay. Now to draw the normal the normal curve, press menu, 4. Now sometimes this works and sometimes it doesn't. Press 9, and normal PDF cannot be computed. Okay, fine. Let's menu 4 and then hide that, and then menu 3 and select all points. All right, now that we've selected all points, menu 4, 9, it still can't be computed. I'm not understanding that. Menu 3, 5, menu 4, 9. Okay. Well, let's go back to our table here. And let's see, let's just put in frequency here. FREQ. All right. And then what do we got for frequency? We got 1, 2, 4, 6, 4, 2, 1. Okay. So we go back to our thing here and click on that, and then we got, let's change it to frequency. Okay. All right. Now menu, actions, select all points, menu 4, 9, and there it was. So it will do it with the frequency, but it won't do it with the relative frequency. All right. And let's take a look at that curve. Okay, it's mound shaped, right? And both the legs are symmetric. Good. All right, let's see here. And that's talking more about doing it on the 83. E does, and then F does. Remember, it was menu 3, 5 and menu 4, 9. Okay, Describe the end behavior of the normal probability density function. Okay, so if you look at it as f of x approaches 0, as f of x approaches 0, okay, as the y gets closer and closer to 0, okay, x increases or decreases without bound. And we'll go back and look at that. Okay, so as x goes out this way here, y gets closer and closer to the 0. It never touches, but it gets closer and closer. Same thing as x goes way out here, it does the same thing. All right. If the area under the normal curve is 1, then what is the area under the curve to the left of the mean? Okay, we discussed that at the very beginning. It's 0.5. It's 50%. All right. Describe how to obtain this area using the bars in the histogram. Okay, let's go back and look. See, you got that inflection point right here, right? And you got that inflection point right there. So add the areas of the first 3 bars plus half the area of the 4th bar. Okay. Oh, okay. Describe how to obtain the area. Okay, let's go back and look. Let's see here. So here is your mean, right? That's your mean, 3.5. So what do we got? 1, 2, 3, and then half of that bar there. Okay. So what do we got? Let's see. Add the area of the first 3 bars plus half the 4th bar. So the first one was 0.05 plus 0.1. And let's go back. And that was 0.2. Plus 0.2 plus 1/2 0.3, and so that's going to 1.5, 3.5, 4.5. That gives you 0.5. Okay. Explain how you can use the bars in the histogram to estimate the area under the curve within 1 standard deviation of the mean, which is the interval from 3.5 to minus 0.014, which is 3.36 to 3.36 to 3.5, 3.36 to 3.64 on the x-axis. Then find the estimate. So let's go back and let's see. So we're looking from 3.36 to 3.64, 3.36. So that's going to be like maybe right there to 3.64. That's going to be right there. And And let's see here. Let's draw that. So we're looking from a little bit off. And 3.36. So we're looking at this area right here. A little bit off. Still a little off. That's better. So we're looking at that area right there. Okay, how can we add up that area right there? The interval captures the middle three bars, so the sum of the area of those bars should give an estimate under the curve, and that, let's see, that would be 0.2 plus 0.3 plus 0.2, which is 0.7. Okay, and let's go back and look at it. So that's and really I took in that little slice and that little slice right there, because if you remember on that first graph, I said that was 68%. Okay, and here I'm coming up with 70%. So I took a little bit more, but it's an estimate. So 70%, that's a pretty close estimate to 0.68. All right. And number 4, explain how you can use the bars in the histogram to estimate the area under the curve within 2 standard deviations. Within 2 standard deviations. Let's use a different color here. 2 standard deviations. So that's going to be 3.5 minus 2 times. That's going to be 3.22 to 3.78 on the x-axis. 3.22 to 3.78. So 3.22, it's going to be like maybe right in there, to 3.78, that's going to be like to maybe right in there. And I'm way off. There we go. That's pretty close. 3.78. So this right here, this that's going to be from right there to right there. And what do we capture here? All right. What do we capture? Well, we captured the middle 5 bars. So the sum of the areas of these bars is going to be 0.1 plus 0.2 plus 0.3 plus 0.2 plus 0.1, which is 0.9. Okay, and then if you go back and if you look, we're not taking that part right there, and we're not taking that part right there, and we said at the very beginning that this was 95%, and so we took 90%. 1, 2, 3, 4, 5. See, that's we're missing that little bit right there. And we're missing that little bit right there. Okay. So, like I said, it's an estimate. All right. Finding areas under a normal curve. Finding areas under a normal curve. All normal curves have the following properties, sometimes collectively called the 68, 95, 99.7 rule. 68% of the data fall within 1 standard deviation of the mean, 95% of the data fall within 2 standard deviations of the mean, and 99.7% of the data fall within 3 standard deviations of the mean. A normal curve symmetry allows you to separate the area under the curve into 8 parts and know the percent of the data in each part. Okay. Remember, half is over here and half is over there. You really don't have to memorize all of it. You can use some arithmetic to find. You saw how I found 2.3% and so on. All right. So suppose you might want to put that on a 3x5 card. Suppose the heights in inches of men ages 20 to 25 years old in the United States are normally distributed with a mean of 69.3 inches and a standard deviation of 2.92 inches. Find the following. All right. The percent of men who are between 63.46 inches and 75.14 inches tall. 63.46 inches is 5.84 inches, or 2 standard deviations below the mean. 75.14 inches is 5.84 inches, or 2 standard deviations above the mean. 95% of the data in a normal distribution fall within 2 standard deviations of the mean. So 95% of the males are between 63.46 inches and 75.14 inches tall. The percent of men who are taller than 72 inches. Okay, so 72.2 inches is 29 or 72.22 inches is 2.92 inches. 2.92 inches. So we took 72.22 and we subtracted 69.3 from it, and that gave us 2.92 inches. Okay, or 1 standard deviation above the mean. When the area under the curve is separated into 8 parts, the parts that satisfy the condition of the height will be greater than 72 inches, have percents of, 13.5%, 2.35%, and 0.15%. The sum of these percents is 16%. And so 16%. And I want to let's just draw a real quick curve right here. That's going to be maybe draw it right here. Okay, so we got and well that. All right, so right here, what does this measure here? That is 69.3. That's the mean, 69.3. All right, and then this first standard deviation, that's 69.3 plus 2.92 inches, which is 72.22. Okay, so what do we know? We know that this print over here is 50%. We know that this part here is 34%. Okay, so we could take 100 minus 50 and 34, that would be 84%, and that leaves you with 16%. Okay, nice and easy. I also want to show you how to do it in the calculator. Okay, let me show you how to do it in the calculator. Let's go here to our calculator, and let's see here. Let's go. Menu 6, 5, 2. And then the lower bound, that would be negative infinity, negative 9 EEE. Our upper bound would be 72.2, I believe it was. 72.2? Yes, 22. And our mean is 69.3. Our standard deviation was 2.92. And then we press enter, and see, that gives you 84. That calculated that calculated. Remember, I said that was 84%. That calculated that. So, how would you find that? You wanted it greater than, so that would be menu 6, 5, 2, and then we have 72.2, 2, and then we want to go to positive infinity, so that's going to be 9 double E 99, I think 9, and then tab 69.3 tab 2.92. Press enter. I don't know how I got that extra dot in there. All right, so that's 15.8%. We would round it to 16. Okay, so there is a little bit of rounded in that. Suppose the height in inches of men 20 to 29 are normally distributed with a mean of 69.3 and a standard deviation. Find each of the following. Okay, and I'm just going to use this curve down here. The percent of men who are between 60.54 and 78.06. So I'm going to use this one here. I'm going to put down here, I'm going to put 69.3. 69.3. That's not working out too well, is it? 60, yeah. Maybe I could get a little, and then, yeah, I'll do that. All right. So that's going to be 69.3. And then if I, 69.3 plus 2.92, that gives me 72.22. 72.22. Is that right? And then plus 2.93 at 75.15. 75.15. And then plus 2.92. 78.07. 78.07, right? All right, so that's real close to that. It was 2.92, I believe. Yep, 2.92. Did I make a mistake somewhere? 69.32. Okay, so all right. Now let's take 69.3 minus 2.92, and that gives us 66.38. 66.38, and then we'll subtract again, minus 2.92, and I'm just making that 63.46. 63.46. 63.46, and we'll subtract minus 2.92. and that's 60.54. 60.54. All right. All right. So there it is. Now, the percent of men who are between 60.54 and 70. Okay. So that's going to be, that's 13.5. Excuse me. 34%. That's 34%. All right. That's 13.5%. That's 13.5%. And then from here to here, 3 standard deviations we know is 99.7%. Okay. And that's 2.35. 2.35. I should have put that in there. 2.35. All right. The percent of men who are shorter than 60.54 inches. Okay. Well, that's going to be, what is this area over here? That's 0.15, I believe. Okay. So this is going to be 0.15%. Okay. Now, let's do it in the calculator real quick. Menu 6, 5, 2, and we were between 60.54 and 78.06. 60.54 tab, and then at 78.06, and let's see, tab, and that was 69.3, 2.92, and that's going to 99.7. Okay, and then less than 60.54. So menu 652. So negative infinity to 60.54. Tab 69.3. Tab 2.92. And that's so that would be 0.134 or 0.15. Okay, a little round in there. Good. Using the standard normal distribution. The standard normal distribution has a mean of 0 and a standard deviation of 1. A data value x from a normal distribution with a mean mu and a standard deviation sigma can be standardized by finding its z-score using the formula z equals x minus the mean divided by the standard deviation. Areas under the standard normal curve to the left of a given z-score have been computed and appear in the standard normal table. This table allows you to find a greater range of percents and probabilities than you can using the mean and multiples of the standard deviation. You know, sometimes you get one that's between those. So this is how you find it. For example, the area under the curve to the left of the z-score 1.3 is 0.9032. The table 000 plus means slightly more than 0, and 1.00 negative means slightly less than 1. So 1.3 would be right there. So 1, 3, that's 1. All right. So let's see here. I want to get a picture of that because I'm going to have to come back to it. So let's see here. All right, I got a picture of it. Suppose the heights in inches of women 20 to 29 in the United States are normally distributed with a mean of 64.1 inches and a standard deviation of 2.75 inches. Find the percent of women who are no more than 65 inches tall, and the probability that a randomly chosen woman is between 60 and 63 inches tall. Okay. To do this, analyze the information. The mean of the heights is 64.1 inches. 64.1 inches. The standard deviation of the heights is 2.75 inches. All right. Now, formulate a plan. Convert the heights to z-scores. Z-scores. And use the standard normal table to find the probabilities needed. First, find the percent of women who are no more than 65 inches tall. Convert 65 to a z-score. That's going to be 65 minus the mean, which is 64.1, over the standard deviation, which is 2.75, which works out to about 0.3. Recognize the phrase no more than 65 inches means z is less than or equal to z.65. All right. Read the decimal from the appropriate row and column of the standard normal table. Okay, so let's go back to our standard normal table. And what do we got here? We're looking for 0.3. So 0.3, and that's right here. 0.3, and that's right there. 0.6179. 0.6179. Write the decimal as a percent. 61.79. Okay. Next, find the probability that a randomly chosen woman is between 60 and 60. Well, let me show you, no more than 65. Let me show you an easier way to do that. You can do it with your calculator. No more than 65 inches. Okay, let's see. Go to her, and it's menu 652. Lower bound is negative infinity. Upper bound is 65. Our mean is 64.1. And our standard deviation is 2.75. Press enter. And the calculator gives you 0.62 or 62.8%, which is real close to what the table gave you. There's a little rounding in the table that's not in the calculator. Okay. All right. Now let's try, let's see. Next, find the probability that a randomly chosen woman is between 60 and 63 inches tall. Okay. So we're going to convert 60 to a z-score. 60 minus 64.1 over 2.75, and that's approximately negative 1.5. And then 63 minus 64.1 divided by 2.75 is negative 0.4. Because the standard normal table gives the areas under the standard normal curve to the left of a given z-score, you find the probability that z sub 60 is less than or equal to 0 Z is less than or equal to Z sub 63. By subtracting Z is less than Z sub 60 from probability that Z is less than Z sub 63. Okay, so we need to find this negative 0.4, and we need to find negative 1.5. So let's go. Let's see here. 1.5, negative 1.5. Negative 1.5 is going to be right here. All right, that's 0.0668. 0.0668, and then we need to find that's negative 1.5, negative 1.0668, and then negative 0.4 is going to be 0.3446. Is going to be 0.3446. So we're going to do 0.3446 minus 0.0668, and that's going to equal 0.2778. So it's going to be 27.78%. So we're looking for 60 to 63. We can do that in a calculator too. Menu 652. Our lower bound is 60. Our upper bound is 63. Our mean is 64.1. And that's 2.75. 2.75. All right, press OK. And we get 27.65. Okay. 27 point. See how close that is? So that's real close. That would be 27.65 compared to 27.78. All right. Not as much rounding there. Justify and evaluate. 65 inches is slightly greater than the mean height. Since all the heights up to the mean represent 50% of the data, it makes sense that all the heights up to 65 inches are slightly more than 50%. Heights from 60 to 63 inches are within the area for heights less than 65 inches, but there are fewer, so it makes sense that the probability is less than 50%. And let me show you what it's talking about. And let's see here. Okay. This is talking about from here to here. Okay. And then on this one here, it was talking about from, way over here to all the way over there. So, and this right here is 50%. So, that right there would make it a little bit bigger. All right. Suppose the height in inches of adult females 20 to 29 in the United States are normally distributed with a mean of 64.1 inches and a standard deviation of 2.75 inches. Find the percent of women who are at least 66 inches tall. So it's going to be a little bit more than 50% because 50% is 64.1 inches, right? So Z equals 66 minus 64.1 over 2.75, and that's about 0.7. Okay, and let's go to our table. 0.7. 0.0.7, 0.7580, right? Okay. All right. So Z 66 is 0.7580. Find the percent of women who are at least 66 inches tall. So we're going to find the probability that Z is greater than or equal to Z of 66. All right. And this right here, that if you draw your curve here, that's right there. That is 0.7580 or 0.7580, and we'll say it's 66. Okay, that's all of that area. So we're wanting to find this area over here. This is the area we're wanting to find. So we know that the entire area is 1, so we're going to say 1 minus 0.7580, 0.7580, and that's going to be 0.242 or 24.2%. Okay, now doing the calculator, menu 652, and we're looking for women who are at least 66 inches tall. So our lower bound is going to be 66. Our upper bound is going to be 9 double E 999, and we got 64.1, and we got 2.75. And what does that equal? 24.244. Okay, so it's not off much. It's not off much. A little bit of rounding in the table, but not much. Find the percent of women who are less than or equal to 61.6 inches. So first we need to calculate our z-score. Z equals, and we got 61.6 minus 64.1. So we should get a negative number, 2.75. And you just put that in your calculator, and 2.75, and that's approximately negative 0.9, 0.9. Let's go to our calculator. Negative 0.9. Negative 0.9, that's 0.1841. Okay. So it's find a percent of women who are less than or equal. So the probability that Z is less than or equal to Z 61.6 was going to be 0.1841 or 18.41%. Okay. Again, you can do that in your calculator, menu 652. Not too bad. Not too bad. Elaborate. Explain how you know the area under a normal curve between mu plus sigma and mu plus 2 sigma represents 13.5%. Okay. How do you recognize? How do you know it's 13 point of the data? If you know the percent of the data within one standard deviation is 68%, and the percent of data between 2 standard deviations is 95%. Okay. Well, first let me kind of block this out here, and we'll draw some little curve here. We'll draw us a curve, and let's see here. and and our mean is right here, right? That's our mean. Okay, so plus 1 and minus 1, and then plus 2. Well, we know that this right here from we know from here to here is 68% of the data, right? And then if you draw that other one over there, and we'll do it in a different color here, we know that this right here is 95% of the data, right? Okay, so and this is the halfway mark, which means that right here we've got 34%, and right there we have 34%. Okay, and then 95, what is 95 divided by 2? Let's see, 95 divided 2 is control enter 47.5. 47.5. So that would mean that over here on, here in the middle here, you're going to have 47.5, and over here you're going to have 47.5. The normal curve is symmetric. So 47.5 minus 34, 47.5 minus 34, that gives you 13.3. So that means that this is going to be 13.5%. Now, let me do that. That's going to be 13.5%. So explain how you know the area under the normal curve represents 13. All right, there's the math right there. Not too shabby. 10. How can you use the 68, 95, 97.7 rule and the symmetry of a normal curve to find the percent of normally distributed data that are less than 1 standard deviation above the mean? Okay. Let's go. Let's see here. And we'll do the same thing we did just a minute ago. All right. So let's see here. And let's draw us a little line here. I'm hoping that the more of these curves I draw, the better I get. But I've been drawing them for years, and anywho, all right. So less than 1 standard deviation here. So we go right here. There's our mean, right? Then we know that this is 50%, and over here is 50%, right? If we go 1 standard deviation here, that's mu plus 1 standard deviation. Okay. How can you use it? We know that this is 34%. Okay, we just did that a second ago, right? So how can you use the 68, 95, 97 rule and the symmetry of a normal curve to find the percent of normally distributed data that are less than 1 standard deviation? Well, let's see, we've got 50 plus 34%. That is 84%. Okay, so 84% of the data are less than 1 standard deviation above the mean. So we're talking about all of this area, all of that area. All right. Essential question check-in. Explain what a z-score is and how it's used. A z-score represents the number of standard deviations that a data value is above or below the mean. Z-scores are used to find probabilities based on the area under the standard normal curve in the standard normal table. All right. A z-score z-score represents a number of standard deviation that a data value is above or below the mean. All right. Z-scores are used to find probabilities based on the area under the standard normal curve and the standard normal table. All right. Great lesson, folks. Thank you very much. You have a great evening, and I'll see you tomorrow in class.